This question has to be read a few times to understand what's being asked here. We're only given one number, and that's the number 1. So we need to generate two sequences, an arithmetic sequence and a geometric sequence, and the first term of both is 1. So for an arithmetic sequence, if the first term is 1, the second term is going to be 1 plus d, and the third term is going to be 1 plus 2d, and the fourth term is going to be 1 plus 3d. For the geometric sequence, if your first term is 1, your second term is going to be 1 times r, your third term is going to be 1 times r squared, and your fourth term is going to be 1 times r cubed. Because we don't really need to include those 1s, I'm going to remove them, because 1 times anything is just what we multiply the 1 by. So the claim in this question is that there is only one sequence that can be both arithmetic and geometric. So we need to find the sequence that's both arithmetic and geometric. So we are then presuming that the first term, which is 1, and the second term, which is 1, can be ignored because that's already set. The second term is 1 plus d and r. So because the second term of the GP is equal to the second term of the AP, we can say that 1 plus d is equal to r. So because 1 plus d is equal to r, we can isolate d, and d becomes r minus 1. We also know that the second term is equal. The third term is equal. So 1 plus 2d is going to be r squared. So we will write down here 1 plus 2d equals r squared. So I'm going to call this my first equation, which I've pulled out of that pair of terms. And this is going to be my second equation, which I've pulled out of that pair of terms. And now what we have is a simultaneous equation, because what NOMSA is claiming, that there's only going to be one sequence that is both arithmetic and geometric with first term 1. We now have to test this. So what we're going to do is we're going to substitute this term, this equation, into this one. So 1 plus 2 times d is equal to r squared. If we remove the brackets, we get 1 plus 2r minus 2 equals r squared. This is recognized as a quadratic equation. Our r squared is on the right-hand side, so it makes sense to bring our terms to the right-hand side and leave 0 on the left and solve. So if I transpose my 2r, it becomes minus 2r. 1 minus 2 is minus 1. If I take it to the other side, I get plus 1. Now I have a trinomial which I can factorize, and that's a fairly easy trinomial to factorize, and becomes r minus 1 squared. If r minus 1 squared equals 0, then we know that r has to be equal to 1. We're now required to find out what d is, and we can substitute our r equals 1 into this equation here. So substitute r equals 1 into equation 1, and we get d equals 1 minus 1, which is 0. So if we substitute these values into the original sequence, because d is 1, we're going to get 1. 1 plus 0 is 1. 1 plus 2 times 0 is 1. 1 plus 3 times 0 is 1. If we were to substitute it into the geometric with r equals 1, we'll get 1. 1 squared is 1. 1 squared is 1. So the claim that there is only one sequence is actually correct. So now that we've solved for r equals 1 and d equals 0, the arithmetic and the geometric sequences are both 1, 1, 1, and 1, as I've written out there in red. So therefore, NUMSA is correct. When there are questions that require some sort of description or justification, it's important that you write some words to explain your argument. You can't just leave the question without answering the original question as to whether she's correct or not.